Hey guys, we're going to look at factoring trinomials today, and we're going to go over two different methods, the area model and grouping, and just giving you strategies. Hopefully one of them clicks and you go and become pro at that. Okay. With either method that we talk about, you first always want to look, is there a greatest common factor that I can pull out? So we're looking at trinomial is three terms. So we're going to look at all three. Is there a greatest common factor other than one that I can pull out from all of them? If so, we're going to do that up front. Then we'll use a product sum puzzle with the remaining trinomial. And then from that point, you decide which way you want to go. So either the area model or into grouping. This video will focus on the area model. There will be a second video for the grouping method. Okay. All right. So look for a GCF for all terms. Pull it out if you can. Create a product sum puzzle. And then we're going to use the area model, just like we did for multiplying, except now we do backwards thinking, okay, reverse thinking, to figure out what multiplied to create that inside pattern. All right, so here we go. This is what it looks like. So first thing I'm doing, I have 3x squared plus 7x plus 2. So first thing I look for is the greatest common factor. So I'm looking at 3, 7, 2. They don't have x in common because 2 is just a constant. 3, 7, and 2, the biggest number they can all be divided by is 1. Okay, so I go to the next part here where I'm going to create a product sum puzzle. Okay, so product sum puzzle, I'm going to take the first times the last, so 3 times 2 will give me my product, so that's 6. The middle term is my sum, so positive 7. Okay, so I need two numbers that multiply to 6 but also add to 7. And I just go through my numbers. If I do 1 times 6, that's 6. 1 plus 6, oh, that's 7. Hey, I love it when it's the first one. Okay, so 1 and 6 are going to be what I'm going to use inside. So now I'm going to create my area model. Okay, when we do this, the squared term is always our first box. The constant is always our last box. And now in here, if I come back to my setup, there's are going to be my product sum factors that I just found out. So 1 and 6. So this is going to be 1x here, 6x here. I could swap those. It doesn't matter. We would get to the same result. Our factors might just be in a different order, but we'd still get the same factors. Okay. All right. So here we go. I need to know what two numbers multiplied to give me x squared. Well, I know for sure it's x and x, because that x times x will give me the x squared. Okay, now it's a matter of, okay, so 3, that's 1 and 3, and figuring out where do I put that. If I put the 3 here, and I look ahead and I'm like, well, 3 times something has to equal 1x, I don't want any fraction pieces, so I'm like, maybe that doesn't go there. So this takes some look ahead thought here. If I do 3 here, 3 times something is going to have to equal 6. Oh, 3 times, okay, so this looks like it could work because I just said 3 times positive 2 would get me to 6x. So that works here. Now I have to see if it works with my x right here. So x times 3x is 3x squared. X times positive 1 gets me 1x. Okay, that works. And then 1 times 2 is positive 2. So now everything works. So my factored form is 3x plus 1 times x plus 2. And you could write it the other way, right? So my factors are just these quantities up here, right? I could have it x plus 2 times 3x plus 1. Those are exactly the same story, okay? That's the area model. So I look for a greatest common factor. I create a product sum puzzle, so multiply the squared times the constant, and then the middle term is my sum. What multiplies to the product but adds to the sum? And then you fill in your box and play and figure out like what multiplies to create that. Let's look at it again. Okay, 9p squared minus 24p plus 12. So I look first for a common factor, 9, 24, and 12. And we learned in a previous class how you could go to Desmos and see what that is. So all of these numbers can be divided by 3. So that's my greatest common factor. There's not a variable because I have a constant at the end, so it's just 3. So if I pull 3 out, I'm figuring out, okay, if I divide all of these by 3, what is left inside? What would I multiply back by? Right, 3 times 3p squared gets me 9p squared. 3 times negative 8p is going to equal negative 24p. And then 3 times positive 4 gets me back to positive 12. Okay, so that's my first step. I had a GCF, pulled it out. That GCF, its only job is to be out front now. Okay. All right, so here we go. Let's look at, we're going to use the remaining trinomial, so what's in our parentheses, to do our product sum. And that's a big thing. The GCF out here, all you're doing is making sure it stays outside the front when you write your final answer. All right, so 3 times 4 is 12. Middle term is that sum, okay? So I have a positive product, negative, so I know that these both are going to be negative numbers. And then I just have to figure out, well, what are they? If I do negative 1 times negative 12, that's positive 12, but that adds to negative 13. So it can't be that. If I do negative 2 times negative 6, that's positive 12. If I do negative 2 plus negative 6, that's negative 8, right? And this is what I want. Oh, sorry, positive 12. That's what I want in my product sum puzzle. So negative 2 and negative 6 are what I'm going to use. Okay. All right. Once I have that, I create my area model. Squared term goes in the first box. Constant goes in the last box. And now I use these two as my remaining terms. I can put them in either order. So I could write it like that. Or I could put the negative 6 here and negative 2 here. And we'll see that we can get to our result either way. Okay. All right, so I know in this first spaces, I know both of them have to have p because p times p is how I'm going to get p squared. Okay, and now I have this 3, and so it's figuring out, okay, 3 is 1 times 3. Those are my options, 1 and 3. I have to figure out where I put that. If I put 3 here, I'm thinking 3p times something here has to equal negative 2p. I'm like, ooh, that's going to be a fraction. So again, that ahead thinking, right? So if I put 3 here, 3p times p is 3p squared. 3p times, oh, if I do negative 2, 3p times negative 2 is negative 6p. So that works, okay? And now I go ahead and figure out the rest of my puzzle. Well, p times what equals negative 2p? Oh, times negative 2. And then I check negative 2 times negative 2. That's positive 4. Here are my factors. So p minus 2, 3p minus 2. And notice my GCF that I found right at the beginning has to be in front. And again, you could write this in the other order. You might end up with 3 times quantity 3p minus 2 times p minus 2. Exact same thing, okay? These are the same thing. They will get us there. Okay, so just being methodical, thinking about like, okay, what do I know? How do I do this? Okay, let's try it one more time. First thing I'm looking for is a greatest common factor of all 3. So this GCF, 6, 14, and 12 can all be divided by 2. No variable because we have that constant. So 2, and then 2 times what gets me 6m squared? That'd be 3m squared. 2 times 7m will get me back to 14m. And 2 times negative 6 gets me negative 12. Remember, you could find all of that by dividing all of this by the greatest common factor, and that tells you also what your remaining factors are. Okay, so we found our greatest common factor. Remember this, its only job is to stay out front, okay? So don't lose it, or else you have a very different story. Now we're going to do our product sum with the remaining trinomial. So 3 times -6 is -18. Mind your signs. Sum is +7. So I have a negative product, but a positive sum. So I know it's positive and negative, and I know that my positive, I have to have more positives when I add it together so that I end up positive, right? And so I just start going. Always start with 1, right? So -1 times 18 is -18, but if I add those together, that's just 17, right? So that's not what I want, okay? I do -2 times 9. Okay, that equals -18. -2 plus 9 equals 7. Oh, hey, those are what I want. So that must be my two values here. So 9 and -2. Okay, so this is going to help us fill in our area model. So we create the box. Okay, we're using the inside trinomial. Okay, remember my GCF is already outside. So 3m squared, -6 is the last box. And now I use my product sum numbers here, and I can put it either place, right? So I have 9m, -2m, and now we figure out what multiplies, okay? So I'm always going to have that variable times itself so that I get that squared term. Again, I have 3, popular number today. So 3, looking ahead, if I have 3 up here, 3 times something would have to be -2. Okay, so that's not going to work. So I'm going to put 3 here. 3m times m is 3m squared, right? 3m times something gets me 9m. Well, I have the m already, so 3 times 3 gets me the 9. 3m times 3 is 9m. Okay, so I got that one. And now I do 1m times something equals -2m. If I multiply by -2, 1m times -2 is -2m. -2 times 3 is -6. Everything works. There are my factors. And again, you could write it in the other order. Okay, these are the same because of multiplication. Just remember that GCF should always be out front. Notice in every one when we had it, the GCF is our first term, and then we have our quantities. Okay, that's the area model. That's how you use product sum to get there. Just being really logical and just having a method. Just go through your factors and like, okay, nope, that one didn't work. Try the next one. Nope, that one didn't work, until you find the one that's successful. As you get better and better, you'll start seeing it a little bit sooner, and you might not have to write down all of the factors to see it. You might be like, wait, I think it's this. But that's the area model for factoring trinomials.